Alright, so I wanted to make sure that you had a solution set to the homework that was due for today. And again, I saw some good attempts, and whether you could get all the problems or not is not important. We're here now, and we're working, and I just want to make sure you have all the solutions. So starting with problem number one, um, this really is kind of based on what we've been doing for the elevator lab. So this idea of a lift force, basically you have the propellers giving us a force upwards. I'll call that L for lift force, and then we have the weight of the helicopter going downwards. And this works very much like the elevator lab that we did. So we have a lift. So now what we want to do is we actually want to use this law, what I'll call Newton's second law, the unbalanced forces law, to figure out what's going on. This is true in all situations. Now what we want to do is we want to apply this to helicopter situation. So we have a lift force pointing up. We have the weight force pointing down, and because the weight points down, we subtract it. And the effect is that the helicopter, which is m, accelerates. So now what we want to do is we actually want to put in some numbers, and what we're trying to calculate is the lift force. So let's just do a little side calculation here. The weight of the helicopter is 4,600 times 9.8. And of course, let's remember that the mass of the helicopter is 4,600 kilograms. So I want to make sure that we're getting these units right. Remember that mass is kilograms and weight is newtons. And so we're going to actually plug in our numbers here. We're going to get the lift force minus, and when I go ahead and get 4,600 times 9.8, that's actually going to give me 45,080 newtons. And the effect is that the 4,600 kilogram helicopter, now the acceleration is upwards, which is the positive direction. So we multiply that by 2. And so we can actually go ahead and we end up getting a lift force, 54,280 newtons.